All right, let's start class. All right, I already have the test here, okay? Don't forget to take them back. Okay, so today's topic is about accolades, section 10.2. In the previous section, we are talking about how to describe a curve using parametric equations, and now we're going to use them to find wait a minute, this is a section 0.2, yes. So the part of, then we're going to describe, this is called calculus with parametric equations. So we can use that to find tangent lines. Yeah, we can also use that to find the area, okay? And we can use them to find the length of a curve. Okay? And also the surface area of some surface stuff. All right, so this is a section 10.2. Okay, we are given a curve in the space. Okay, and this is given by parametric equations x t y equals y t. Okay, suppose at that point I'm going to denote that point x naught y naught, right? Which is going to be determined by the time t naught. Okay. So how can I find the tangent line? Right? Tangent line, remember the equation, you just need to know the slope. Okay? The slope of the tangent line at the point x naught y naught, right? If you can view it locally as a graph of function, okay, this is going to be dy dx when x equals, right? Okay, this we view y as a function of x, but now there's a parameter describe x and y. But that's okay. Use a chain rule, we can have the this is going to be the ratio of these two derivatives. And how to get x naught, then when t equals t naught. So this is a simple form. Then you can find the equation for the tangent lines. Okay? Yeah. For example, you are given the parametric equation for the curve x equals t squared, y equals t cubed minus 3t. Right? Find the tangent line, right? At the point, this is still pointing the x, y coordinate system, okay? Find the point at this. Yeah, how to do that? Well, it's hard to draw the graph. Okay, it's impossible, almost impossible. So what I'm going to do is I'm going to determine the t value for which the curve passing through that point. So I get t squared equals 3 and t cubed minus 3t equals 0, right? I determine that. But the second equation, this is going to be, t. The second equation is t and the t squared times 3, right? Equals 0. So clearly, t equals 0 is, t cannot be 0 from the first equation. But clearly, t squared equals 3 is going to be solution. So that implies t equals plus minus square 3. So you get 2 values. What does that mean? That means so this is a picture, 3 and 0. That means the graph passing through the curve passing through this point twice. Okay, at the time when t equals negative square 3, also when the time t equals 3, coming back to that point. So if we're talking about tangent line to this curve, you're going to have 2 tangent lines. Okay, tangent to the one curve and tangent to another curve at the same point. Okay, so you got two values. So you get 2 slopes. The point is still the same point, but the curve, because it's going to be, yeah, it's passing through this point, right? So yeah, let's find the derivative. Dx dt is going to be 2t. dy dt is going to be 3t squared minus 3. Okay. So the slope when t equals square root 3, the slope I call that the positive slope. Okay, it's going to be the value of 3t squared minus 3 over 2t when t equals square root 3. Okay, right? So it's a dx is at the bottom. So you simplify it, you will get 2 square root 3 and 3 times 3. Okay, t squared equals so minus 3. Right. So after you simplify it, you get 9 minus 3 is 6. 6 divided 2 is going to be 3. Or you can also simply write it like this. Okay. When t equals negative square root 3, it's a slight difference. I think the only difference is this is going to be still going to be 3 minus 3, 2 negative square root 3. So the answer will be negative square root 3. Okay. All right. So you got 2 slopes, positive and negative. So you get 2 tangent lines. The first one, yeah, y 0, right? It's a positive square root 3 and x minus square root 3. No, x, sorry, not x. X is going to be 3. Okay, x is going to be 3. The second one is y minus 0. It's negative square root 3, x minus 3. So you get 2 tangent lines and to this particular curve. Okay. Using the above formula, you can find high order derivatives. Okay. For example, if you have x of t, y called y over t, right? We can express dy dx, d squared dx squared in terms of t. Okay. So we can do that. How do you do this, right? I already did it for the first one. So dy over dx, right? It's a derivative of y with respect to x. By the chain rule, it's going to be dy over dt, dx over dt, right? Yeah, in other words, it's just y prime t, x prime t, okay? All right, so how can I find the second derivative? Okay, the dependency of a y on x is implicit. Okay, y is a function of x, but we don't want to write down it cannot, most of the time we cannot write down the expression for the dependency. Yeah. So we still can find the second derivative. By definition, the second derivative is given the derivative of the first derivative, right? Since the first derivative is already a function of t, right? The first derivative. So in other words, this is going to be like that. Yeah. So you've used this as another variable, right? So that would be dy over dx and dx dt. Okay. Yeah. Okay. Or another way to think about this, yeah, this is a derivative. So let me rewrite it. So this is a d and a d. So this is a new variable. So it's to be d dy dx and dx. How about like that? Yeah, it looks better. Then the derivative is another variable, right? Quantity. Okay, like in physics, the derivative is a velocity function, right? For example. All right, then you can divide both the numerator denominator by dt. Then you get, right? Okay. So what do we have here? For the simplicity, you can, yeah, you have to use a chain rule to figure out this. Okay. So this will be dx dt, d dt. What is that part? This is actually dy over dt and dx over dt. So you can use a quotient rule to find the derivative. If you use a quotient rule, this is a quotient, so it's d p dt square. Then the derivative of y was, yeah, that will be the second derivative, and put the denominator minus dy over dt and the derivative denominator. Right? So eventually you will get x prime t cubed. And here's y double prime t. And x prime t minus y prime t and x double prime t. You will get something like that. That was for the second derivative. Right. Okay, so that's it. This is that shows you how to find the second derivative. But we are more interested in the length of the curve, or the surface of revolution, the area of the surface of revolution. Okay. As I told you before, if you have a curve, right, and this is an arc length s, right? So the length is going to be just integral of ds, depends, okay? But this is, of course, it's almost impossible to find the arc length. So you have no way you can integrate this, okay? So L is going to be the length, okay? So what I'm going to do is I take a point x and y, right? Take the point what's called x and y. Then I can figure out what is ds. I know that ds is going to be square with dx square plus dy square. So you can take any variable out. Okay? So you can take dy out. You can also take dx out. Okay? Now for this new section, you can also introduce another variable for right. If the curve is parameterized by x of t, y over t, then you can also divide the dx dy by dt. So you get, so this is another way, okay, to express ds. So if you know how to describe if you know how to parameterize the curve, okay, then if you already know the interval from alpha to beta, then the length is going to be x prime t squared plus y prime t squared dt. T is from alpha to the beta. Right? And this is very useful formula. Right? For example, for the circle, right? If you use the other method, it's very difficult to find the length of the circle with radius r. For the circle, okay, an arbitrary point x and y are given by this equation. Okay, so locally you can view it as a graph of the sum function, right? The circle consists of two pieces, upper semicircle, lower semicircle, and that described by the three equations. It's more complicated, yeah. But anyway, in order to find the length of the circle, you just need to find the length of the semicircle. Then you use one of the above formula, right? Okay, you can do that. So we can try. Let's do this. Okay, we can parameterize a circle in the form. Yeah, you can use a t or theta, doesn't matter. Okay, theta. Let's use theta. Theta is between 0 and 2 pi. Okay. Then dx is going to dx d theta square, dy d theta square, d theta. Right? But when you differentiate, you get r negative sine theta, r cosine theta square, and d theta. So you simplify it, you will get r square inside the radical, then you can just r. Everybody knows that sine square plus cosine square equals 1. Right? So it's just r d theta. Okay, r d theta. R is independent of theta. Okay. So the length of the circle from 0 to 2 pi just r d theta. And r is constant. The integral from theta to 2 pi is just 2 pi. So you get 2 pi r. Okay, so simple. Okay, but if you use the other formulas, it's more complicated. That's the advantage of using parametric equations for the curve. Okay. Yeah. Imagine if you want to use it works, but the computation is more complicated. Okay. So so another way you see, I remember, right? The semicircle, right? So the length is twice of the semicircle from negative to positive. The length of the semicircle, right? What you're going to do is it's going from -1 to +1, and then ds. So 1 plus dy x squared and dx, right? Yeah. Then you have to differentiate that one. You see that it still works, but it's complicated. When you differentiate that, I can quickly give you the answer, but maybe you have to do the computation. Okay. So derivative of this radical square root of r squared minus x squared will be something like that. Okay. Then after you simplify, this depends on arbitrary scale. Sometimes you make mistakes. Okay. You will get r squared minus x squared, r squared minus just r squared. Okay. Finally, you end up with this integral. Okay, then what? You're in trouble if you forgot the trigonometric substitution. Okay, if you still remember, then okay. Now, when I was grading the test, there was an integral involving r squared plus x squared. There are at least 5 students use wrong substitutions. R squared plus x squared. X should be equal to tangent theta. R squared minus x squared. X should be equal to r sine theta, right? But if you use the wrong substitution, it does not work. You have to stop that and go back. Just like a driving, you get in dead end, right? You have to make a U-turn. Don't just keep driving, cut along to the wrong place. You never come out. So that's a very natural idea. So you find out the integral is so complicated, it's not working, means you immediately should say that you enter the wrong place, right? You have to back up, look at your substitution. Is this the right substitution or not? Right? Yeah. Don't just keep it computed, then you have to go to another page and come to see me. Can I write on the side? Well, that's the wrong idea already. If you have to write on the other side, okay, that means more likely the idea is not the best idea to solve the problem. Okay, so this one you have to use substitution, but I don't want to do that because you see that it's getting more complicated compared to the first integral, right? It's so simple after simplifying, just integral of the constant r, right? Then you get the length, arc length. Okay. Okay. Yeah, so let's try the next problem. Okay, this is an interesting problem. So find the length of one arch of the circuloid x equals r theta minus sine theta, and y equals r 1 minus cosine theta. So actually we are talking about the polar coordinates here. Okay, so fixed r is a fixed. How do we describe this graph? It's a little bit, there probably the several circles here, right? So we want to figure out one piece, okay? So this is a picture x and the y. X is going to be, actually continue increases, but this value could be, first of all, it's positive, okay? When it's going to be 0, when theta equals 2 pi, okay? When theta equals 2 pi, it is going to be 0. Okay. So 1 minus cosine theta never be negative. It's always about it. But then you should look at when y equals 0. Okay. Y is always positive. Okay. Greater than 0, less than 2. Okay. So when y equals 0, when this is going to be 0, when this is going to be 0, theta is going to be 2k pi. Okay. Yeah, when cosine theta equals 1. Only when theta is 0, 2 pi, 3 pi. So this is a graph we're going to get. Okay, it's not sine curve. Okay, x is keeping increasing. Okay, y-axis is increasing. Y-axis is increasing from 0 to 2 pi. Okay, you can check that dx d theta equals r, right? And the 1 minus cosine theta. Again, right? And this is a positive. In most of cases, it's positive. So this is a positive for theta between 0 and 2 pi. So as theta increases, x increases. So this is when theta equals 2 pi. Okay. Okay. When theta equals 2 pi, where's the x? Y is going to be 0. What is x? Okay. X is going to be 2 pi r. Okay. X is going to be 2 pi r. So when theta equals 0, x equals 0, y equals 0. When theta equals 2 pi, x is going to be 2 pi r, y is going to be 0. Okay? So this is and the x increases when theta increases, going like this. Okay? When theta increases, x increases. Oh, but the y increases and decreases. Yeah, otherwise it's not touched on the x-axis, okay? And it's going to be like that again, okay? So we are going to find the length of this whole piece in the space, in the xy plane, okay? How do you set up, right? You have to find the derivative y or derivative, yeah, derivative y with respect to theta. It's going to be r sine theta, right? So this is negative cosine theta derivative sine theta. So now the s arc length element is going to be square root of dx d theta square dy d theta square and d theta, okay? And the problem is I have here r 1 minus cosine theta square plus r square sine square theta. So this cannot be simplified to constant. It's not. Okay. What you can do is you take a r out. The inside is 1 minus twice of cosine theta plus cosine square theta plus sine square theta. The only simplification you can make is this can be replaced by 1. So you get 2, right? 2 minus 2 cosine theta d theta. How can I evaluate this integral? Okay, let's find the length first. It's going to be from 0 to 2 pi r. You have to evaluate this integral, right? How to evaluate this integral? It's a radical, but it's not too bad. We can change it. Okay, we can make a inside as a square. Okay, we know that. We know that cosine, right, theta is using double angles, right? It's going to be 1 minus 2 sine square half of the angle, right? Yeah, this comes from cosine 2 alpha equals 1 minus 2 sine square alpha. Just alpha replaced by, 2 alpha by, replaced by theta. Okay, so 2 minus 2 cosine theta equals 2. 1 minus cosine theta becomes 2 sine square half of theta, okay? Yeah, 1 minus cosine theta is going to 2 sine square. So it's going to be, 2 square. Okay, great. So L equals integral R, and that is a 2 square sine square half of theta d theta. Then you take get rid of a square, and be careful whether sine half of theta is going to be positive or not. Okay, first of all, you write down this 2r absolute value of sine half of 2 theta before you get rid of absolute value. But since theta is between 0 and 2 pi, so half of theta is between 0 and pi. Sine value of the angle between 0 and pi is going to be positive. So you can safely remove the absolute value. Okay. Then you find the antiderivative of this function. This will be 2r, and the cosine half of theta, or this should be negative, and divide by 1/2. That's multiplied by 2. When you differentiate, you get sine half theta. All right. So now I'm going to plug. That's negative 4r cosine pi minus cosine 0. Cosine pi negative 1, minus 1, negative 2, negative 2 times 4, negative 4 is 8. So 8r. Where's my pi? I have no pi. So it's no pi. That's no pi. 8r. Okay? So that's no pi. So this is the formula. Right. Where's about the surface of the area of the surface of revolution? Okay, and you can also use if the curve is parameterized by another variable, you can also use you can also change the integral to the integral with respect to that new variable. Okay, so so if you have a curve, right, you rotate around the axis, some axis. Okay, so this is you have to draw this. It's cut short. Okay. Yeah, drawing is it's a necessary basic skill. I'm not good. Never. My father did not have money for me to learn drawing. Actually, so that's all I can draw. Okay. In the school, we never learn this. Yeah. Okay. Do your best. Okay. Draw it. Draw the sphere. I practice many times. Draw the sphere. Otherwise, so many times you have to draw the sphere when you're teaching, right? Okay, so this is this is a surface of revolution. Okay, so this is a curve you're going to talk about, right? Remember, right? So this will be ds, and that piece can be approximated by the surface area is going to be 2 pi r ds. What is r? R is that radius. Okay. So if you are able to replace ds by another parameter up here, you have to do that. Otherwise, it's almost impossible to evaluate the area. Okay, so surface area is going to be dA. It's going to be 2 pi r ds. Okay, that's the idea. It's magic, right? So this will be a single integral. Now, if this curve, here's a point x and y, right? If it's supposed to be in the xy plane, okay. So if this is a curve, if this is a curve given by x equals x of t, y equals y of t, t is between alpha and beta, then what I'm going to do is I can change ds to dt. Okay, so 2 pi, r is still r. I have to figure it out. Okay, how does it depends on x and y, but at least ds is going to be dx of dt plus dy of dt square and dt, and I know it's from r, but you have to express r in terms of t based on the picture. No picture, you cannot do that. All right, so let's look at the problems from the book. Setting up the integral is very important. When I was grading the quiz, not quiz, that's a test. Okay, that was a problem. At least you have to set up an integral, but there are about 5 students did not set it correctly. The picture is wrong also. Okay. Okay. So here, let's find out where's the problems. Okay, let's look at. On the other side of the page. Set up the integral that represents the area of the surface. Okay, so we just want to set up the integral right now. Okay, so here, so the curve is given by this equation: x equals sine t, y equals sine 2t. T is between 0 and pi over 2. The rotation is about the x-axis. Okay. Set up integral for the surface area. Set up an integral for the area, okay, of that surface. Okay. Should I draw the curve? I think it's better to draw the curve. Okay, otherwise you cannot figure out the r, right? So you draw the curve. x equals sine t, y equals sine 2t, 2t. But x, when t increases, when t equals 0, x equals 0, y equals 0, okay? And at least as the end point. Where's the end point? When t equals pi over 2, x is going to be 1, y is going to be 0 again, right? Sine pi. So when x, so here t equals 0, here t equals 1. But then you think about imagine, it's really don't need the exact picture, okay? When t increases, the x value always increases because t from 0 to pi over 2, sine x is increasing function. So x increases from 0 to 1, okay? But the y value increases first, then decreases. Why? Because when, where's the point where decreasing, right? When t equals pi over 4. So when t equals pi, so I think this is a picture, like a I don't know how does it look like. It's not sine curve, okay? Some curve like that. Now you're going to rotate it about this x-axis, okay? So set up an integral, take arbitrary point x and y, and draw the radius r. Clearly r is going to be y, okay? Then, okay? And the y is going to be what? Y is going to be sine 2t right now, okay, for that particular point. And ds is going to be dx over dt squared, dy over dt. Okay, I don't have a battery. I just ordered 4AAA battery on internet. I couldn't find it. Okay. Yeah, you can buy lots of things, everything almost from eBay. Whenever I tap it, shows up. Okay, so this is going to be the derivative of xt. Okay, it's going to be cosine t squared. Okay, here, and the derivative of yt will be cosine 2t squared. So, right, 2 cosine 2t squared. Okay, dt, not too bad. Okay, so you set up integral, right? Then the area is going to be, first of all, you write down 2 pi r ds, okay? The next, you have to put the variable here, 0, pi over 2, 2 pi, what is r? Sine 2t, what is ds? Cosine 2, cosine, right? You write down all the details here. Cosine square t plus 4 cosine square 2t and dt here. So this is the integral. Now, maybe you cannot evaluate, but you have a software on a computer. You just type in the function, then bing, you get answer. Okay. Yeah, you have to understand each part. What is r? Yeah, I'm going to discuss the last problem from the test today. Yeah, we're talking about surface integrals. Okay, so number 60. Okay, x is still equal to, this is x, y equals t plus p to the first half, t is between 0 and 1. Okay, so this is a notation about the x-axis. Okay, set up an integral for this. Well, if you don't want to draw the graph, probably okay, but sometimes you make sure the curve is above the x-axis. Sometimes the curve may be below the x-axis, be careful about the radius, okay? So if I change y to here's negative t to the fourth power, that'll be below the axis. And you still can rotate the general surface, but when you express the radius, be careful, Okay, so if we modify the problem a little bit, so here, let's see, t squared minus t cubed. So when t equals 0, clearly x equals 0, y equals 0. That's your starting point. Okay, when t equals 1, x equals 0 again. Oops. Y equals 2. Right? Now you're in trouble. Where's the point? Here's the point. Right? So how does the curve look like? Y is keeping increasing when t increases between them. But the x is not necessarily always increasing. X could be decreasing, but is this positive? Let's look at the x. I want to see it's on the right side or left hand side. I take t squared out. It's 1 minus t. I think it's positive, right? Yeah, so that means x is always on this side. So this should be the curve. Okay, this should be the curve. Now, you're going to locate about the x-axis. So the graph looks like that. Right? Now what? Okay, so this is this is a picture how it looked like from the outside. It looks like a UFO. It's hard to believe that's a UFO or not. So many videos on the internet. Okay, do you believe that, or just those people have nothing to do, just create so many videos? So anyway, this is a type. Okay, so how do you find the surface area of that piece? Right. So the idea is that the original piece, take a point, x and y, then you have to figure out the radius, right? So the surface area is going to be the integral 2 pi r ds, right? I is going to be y, again, because it's rotation by y-axis. But the x, so it's going to be t times t plus t to the fourth power. But then ds, right? ds is going to be integral of x prime t squared, y prime t squared, and dt. So x prime t, x is going to be, right? So it's going to be 2t minus 3t squared, and the y is going to be 1 plus 4t cubed and square dt. Okay? Yeah, this is a function t squared minus 2t minus 3t squared and squared. So it's a very complicated function, but it's anyway, it's a function, right? So the area is going to be integral from 0 to 1, 2 pi. I is going to be a y variable. Y is going to be t plus t to the fourth power, right? Everything should be expressed in t, and here will be 2t minus 3 squared and 1 plus 4t cubed squared and dt. Yeah. We don't know whether we can evaluate the integral by hand, but at least you can enter it to any programs like Maple or MATLAB. You can get, first of all, you don't get, sometimes you get nothing. You cannot get like a pi over something, a very specific number. And then you give an instruction, give me the numerical estimate, and they give you the number, okay? Sometimes that's all you need to know, right? All right, so this is the integral, and let's do one more, okay? Because I want to do the, the surface part, surface area generated by rotating, now this time by y-axis, okay? Right. So x equals 3t squared, y equals 2t cubed. Okay, t is between 0 and 5. I have to carefully check. I cannot see it. It's too dark. You know why I gave the quiz wrong? Difficult. When I copy the problem to the quiz, the light was so dark. I type it wrong. It's a square. I typed a cube. And nobody can evaluate as integral. That's why it took so long time. Right. So I just say set up an integral is enough. Okay, I will tell the grader. Okay, because there's no way they can evaluate the integral. Okay, so the notation is about the y-axis. Right. So how do we draw this graph? Okay, draw this graph first. Okay, you need to look at where is it when t equals 0. The starting point 0, 0. But when t equals 5, x is going to be 5 square, 75. That's a huge number. Okay, 2 times 5 cubed. It's going to be more than it's 250 maybe, right? Anyway, it's somewhere here. Okay, somewhere here. So this is a curve. Okay. It's never been negative. It's always in the first quadrant. Okay, and then rotated about around about y-axis. So for an arbitrary point x and y, you need to practice. You know, if you understand, it's easy. You know, and enjoy it. If you don't do enough practice, you're not able to solve the problem quickly. All right, so the radius, first of all, you have to figure out what is the radius. For radius this time is x. But x is given, right? It's easily given. It's given 3t squared. Right? And then that's it. You know, then you have a ds, dx dt square, dy over dt square, and dt. So you see, what is dx? 6t squared. What is dy or dt? It's also 6t squared and square, right? Yeah, dt. So you take t out. Okay. So let's find out the length as the surface area is going to be 2 pi r. R is x. What is x? X is 3t squared. And then ds is going to be this. Okay, 6 squared t squared, 6 squared t to the 4th power dt. I think I'm going to take a t squared out. Okay, it's from 0 to 1 to 5 actually, not 1. Yeah, it's from 0 to 5. All right, so let me take 6 out, take a t out. It's 1 plus t squared dt. Not too bad. Okay. (36 pi t cubed). How do we evaluate this integral? Substitution, right? So substitution, let u to be 1 plus t squared. Then du equals 2t dt. I need to need 18 here. When t equals 0, I get 1. When t equals it equals 5. 25, so it's 26. And what is t squared? T squared is going to be u minus 1, and u to the 1/2, and du. Okay, so you can evaluate this integral quickly. All right, so you get, then you find the antiderivative. Yeah, this t cubed is going to be t squared and the t, right? This t goes with dt. Okay, half of dt, 2t dt. T squared is going to be u minus 1. Then you find the antiderivative of this. It's going to be u to the 3/2 minus u to the 1/2. That'll be 5/2 u to the 5/2 minus 2/3 u to the 3/2 antiderivative. Right? And I don't think you can evaluate. So you just leave this number here. Don't touch it. It's in the minus 18 pi and 2/5 minus 3/5. Okay. So I don't think we can evaluate because this is a number, right? It's the exact value of the area. The surface is so strange, okay, because it's created by area. Okay. So I'm going to look at the test problem. There are a few students I have to write the email to them because not doing well, not here. I did not see him online. Okay, and actually sometimes I send an email to them. Hey, can I see your homework you did? Because I claim that your homework is something they couldn't show to me. Okay, so yeah, that's a problem. If you can show it to me, then we have several students doing pretty well. Okay. Yeah, so let's look at the last problem. It's not last problem, the one before last. Find the exact area of the surface. Right? But at least the setting should be correct. Okay, the surface is rotating by this function. The x is already given. Okay, it's about the rotation is about the y-axis. Okay, it's harder to draw the graph, but you have to draw the starting point and end point, right? X-axis, y-axis. So when x equals 1, right? What is the y value? Y value is a quarter minus 0 because natural 0, natural log of 1. There's still some students don't know what is that value. Natural log 1. Natural log 1 is 0. It's quarter. Okay. And the ending point is when x equals 2. Y is going to be 2 squared to 1, right? Okay, this is a positive number, okay? Yeah, it is positive. You can check whether it's increasing or not, the function. It's the increasing function. Okay, anyway, so here, x equals 1, y equals 1. When x equals 2, somewhere, doesn't matter. It's, yeah, somewhere, it's, we don't know, just draw the curve, okay? So your surface looks like that. Right? Okay. So some students trying to solve for x in terms of y. It's impossible. This is the way they design. They don't want you to solve it. Okay. And if you, this is rotation by y-axis, so here the radius is r, and this is a point, right? Clearly I equal to x. Then something trying to solve for x. That's ridiculous. You cannot solve for x. Okay. So ds is going to be, yeah, write down the formula first for why you have to find the ds, right? Because the area is going to be integral 2 pi r ds, right? So you have to decide which variable you're going to use. You think about it, okay? You can have two choices. You can use dy, you can use dx. But if you use a dy, you have to express x in terms of y. Can you do that? No. So you have to use dx variable. Okay? So it's going to be from 1 to 2 pi r ds. So it's going to be d, it's 1 plus dy dx squared dx. Okay? So I is going to be x. So perfect. Everything's x. Right? Yeah, if we understand how do we get r, how the ds, then there's no way you can go. Just you have to use dx, not dy, unless you don't understand, the integral, the integral, right? So now, yeah, because you cannot change it, you cannot express r in terms of a y variable. Only impossible. Okay, I cannot do that. Yeah, I cannot solve for x in terms using elementary function. You have to create a new function, name of it. All right, so now you get 1 plus the derivative of y with respect to x will be x over 2 minus, I think this is going to be, yeah, half of. So this is a typical problem. I think before even if you did enough exercise, you already know what is going to be. Right? You know this is going to be, after you put the inside here, you know you're going to change it to this without any thinking. Okay? Right? Yeah. If you did enough exercise or look at my notes, many problems like that we end up with a square after you put, yeah, move, yeah, combine with a 1. So then you get half of x plus that. Then you multiply this out, don't keep it. Half of x squared plus 1, right? X cancel out. Then you find the antiderivative. Right. You find the antiderivative, you get, what is that? 1 over 6x cubed plus half of x. Okay, I shouldn't, if once it's the antiderivative, I shouldn't put the integral there. It's from 1 to 2. So the rest of that, okay, I cannot guarantee you always get the right answer, because this is depends how many exercise you did when you're in 5th grade. Okay, you simplify, right? It's 2 pi 1 over 6 plus 1/2, right? This is a good exercise. If someone is already in 5th grade, you can give them, can you simplify this to me? Right? They can test us if this child is already good enough in 5th grade. Okay, they already learned to cube. Okay, 5th grade skill. Yeah, next time when you meet someone, right, you can ask. Right, so it's just fraction, add them together and then remove the parentheses, right? So let's do it, and I'm not sure I'm not sure I'm good about that. So after simplifying, so 3, that's 4 plus 1 minus, how about this? It's going to be, combine them, 1 over 6 plus 6 over 3, right? So it would be 4 over 6. That'll be 2 over 3. Right? Then it would be 2 over 3 plus 1. Be 5 over 3. Do you remember you got 10 pi over 3? Or no? Okay, that's a 10 pi over 3. Right? So that's good problem, exercise for kids. Yeah, you have to emphasize, you have to, you really have to pay attention to your future kids. You're going to have kids anyway, right? Most of them. Pay attention to your mathematics. Okay, if they're not good, how do you get them, right? There was another called a coma, some kind of programs that just go over there and practice. If you are so busy, if you're not busy, you have to really pay attention, okay, to their math, okay, and so they can have an easy life in the future if they go to colleges eventually, okay. So you have to practice enough, like add them just together, simplifying. Yeah, you can make lots of problems like that, okay. So I have to spend 1 hour every Sunday to teach my child mathematics in the basement. I put a blackboard there. Okay. because I cannot trust the public education system, honestly. Yeah. So from the 5th grade, I'm not going to teach them before that. Too much work. Yeah. So start teach them, then they do well. Yeah. So they have no problems. And so, so my daughter called me, hey, Daddy, I still have some time left before graduation. Can I get a degree in mathematics? Oh, great, go ahead, do it. So she took a couple more courses, then she get another degree in mathematics. She's not going to use it, but at least she's good in math because of me. Okay, so I promised my wife I'll do that. Otherwise, I'm not going to produce them. So that's your responsibility in the future. Okay, if you have a cat, just remember. Okay, so I'm almost done with today's lecture. Look at so next section will be polar coordinates, and after that we are going to enter the most challenging chapter, which is chapter 11. Okay, pay attention. So those students who are not in my class, don't skip my online lectures and complete the homework every time. Okay. And I do want to see your homework someday. If you come to my office, can I get a C, not C minus, something like that? I really want to see your homework. Okay, your efforts you put there. If you didn't put your effort, you don't need to come to my office anymore. So that's always, I believe that. Okay, so talk to you. See you Wednesday.